Okay, we're going to review some stuff from first semester of chemistry that hopefully kind of dust the cobwebs off of and it'll come right back. In this review, we're going to focus on some mathy stuff like unit conversions, either with units outside of the metric system or going between Tevor conversions, some conversions with the metric system where we're just moving the decimal place, and scientific notation going in and out as we need to. Okay, so let's start with this. Convert 3.0 pounds into ounces using this conversion factor. Okay, so the data that we are converting is 3.0 pounds, and whatever data we're giving goes out front of this. So we're going to be changing this 3.0 pounds. Okay, so whatever data we're trying to convert never goes in our conversion factor. That's supposed to be the relationship between the old unit we're trying to get rid of and the new unit we're trying to get to. So I don't want to throw in my data in there or something like that. So I want to convert this 3.0 pounds. Oh, that was really bad. Let's try that again. There we go. So I want to get rid of my pounds unit, and I want to change this into ounces. Okay, units are kind of like variables in that we can kind of cancel them out and remove them if we have them kind of on both sides of a fraction bar, kind of on top and bottom. Kind of like if you have 2 over 2 or x over x, kind of cancels out, right? So if I have pounds on top over here, kind of in the numerator, and pounds on bottom in the denominator down here, when I multiply this through, and I'm going to have to divide by pounds, those two are going to end up canceling. Okay, now what I want to get to and what I want to keep is the ounces unit. So I'm going to put that on top here. So once the pounds go away, the ounces are left. So all I need now is a relationship between ounces and pounds. And I need to make sure I put the numbers in the right places. So we have this conversion factor that 1 pound is 16 ounces. Okay, I just need to make sure to put them in the right place. I have pounds on bottom, so it cancels out. So I'm going to put the 1 pound down here. My 16 ounces is going on top with the ounces unit. So if I take, let's get a different color here. Let's do orange, I guess. If I take this 3.0 pounds and I multiply by 16 and divide by the bottom, which is just 1, I should get my answer. Okay, my pounds units are going to cancel out. So it's going to be left is just my ounces answer. We're going to plug that into a calculator. 3 times 16 divided by 1 times 16 divided by 1 gives us 48 ounces. All right, and that is our answer. Okay, and you can do this for any unit conversion where we know the relationship between the old unit we're trying to get rid of and the new unit we're trying to get to. Okay, let's move on to another one. Convert our answer from question 1 above, this 48 ounces, from ounces into grams using this conversion factor. Okay, so we're going to continue on with this. All right, so our 48 ounces is going to be our piece of data that we're going to convert. So let's put that here, 48 ounces. Okay, and then I kind of ran over my conversion factor here, but it's 1 ounce is 28.35 grams. Let's see if I can at least put the point back so we don't lose that. Okay, so now I got to figure out which goes on top and which goes on bottom. My old unit is always going to go on bottom, so I could cancel it out. It's going to be on the opposite side of what I'm trying to cancel. So if I'm trying to get rid of ounces, I want ounces to be on bottom here. Okay, which means my new unit that I'm trying to get to, which in this case is grams, is going to be on top. Right there. So when I do this, I'm going to end up canceling out my ounces. Okay, and the relationship is 1 ounce is the same as 28.35 grams. And in this case, I don't have 1 ounce, I have 48 ounces. So by multiplying by the top and dividing by the bottom, I should get my answer in grams. So I take 48 times 28.35 divided by 1, and I get about 360.8 grams. And that is my answer. Okay. In number 3, we're going to show how we don't really need to do these as separate problems if we know getting to grams is the goal from pounds. So I don't have a conversion factor that goes straight from pounds to grams, like how many grams are in a pound. But I do have pounds to ounces, and I do have ounces to grams. And if I don't want to stop in between, like if I don't care how many ounces there are, I can actually put these two together in kind of a string and a chain and just do it all at once, do all my multiplying and dividing at the same time to get straight to my answer. So let's look at that. Okay, so in this case, we have 2 fraction bars here, okay, and they're kind of butted together. So we're going to start back from where we started at in question 1 with 3.0 pounds. 3.0 pounds. Okay, just like before, I want to get rid of pounds first, which means that has to be my first unit on the bottom of this first fraction bar. That way it'll cancel out. Okay, what I'm converting to first is ounces, because I do have that relationship between pounds and ounces. Okay, that relationship was 1 pound is 16 ounces. So this should help me cancel out my pounds, and I'll be left with my ounces unit right here. But if I'm not done there, I can continue on and get rid of this unit next. If I wanted to get rid of ounces, I just have to make sure it's on the bottom of the next fraction bar. So rather than kind of calculating and stopping here and getting an answer and then moving on to another separate calculation, I can say, hey, I'm not done yet. I don't want ounces, so I'm going to get rid of it next by putting it on the bottom of my next fraction bar. And what comes up next on top is the next unit I'm trying to get to, which is grams. Okay, well, what's my relationship between ounces and grams? I just had it up here. 1 ounce is 28.35 grams. So, got my 1 ounce down here on bottom. I've got my 28.35 grams on top here. Okay, so these are 2 separate conversion factors. I've got a relationship between 16 ounces and 1 pound. I've got a relationship between 1 ounce is 28.35 grams. Okay, now in this case, both of these ended up with a 1 on bottom. That doesn't always happen. So don't think like, oh, okay, anytime there's a 1 in the conversion factor, the 1 goes on bottom. That's just by chance. It just kind of depends on how you're canceling your units and what the relationship is between these. So like you could probably also do like 1 gram is like 0.035 ounces or something like that. Okay, and it could be upside down that way, the 1 on top and then the 0.035 or whatever on bottom. Okay, but this works out kind of math-wise the same way, where now our ounces would cancel. And this is what our math and our calculator would be like. We've got to be multiplying by the stuff that's on the top of the fraction bar and dividing by whatever's on bottom. Multiplying by whatever's on top, dividing by whatever is on bottom here. Now, the order of multiplying or dividing doesn't matter here. So you could multiply all the stuff on the top and then divide by all the stuff on the bottom. Or you could do it like me where I do kind of multiply, divide, multiply, divide. You could divide first if you want and then do all the multiplication. Doesn't really matter, okay? As long as your original piece of data is what we are using to kind of start the calculation. You cancel out your old units on bottom by dividing them, and you multiply on your new units to tag them on. Okay, and if the new unit you get is not the one that you want to stop with, you just keep going to cancel out that unit and get the next unit you can calculate and convert to. Okay, either way, we should end up at the same answer, which should be about, oops, let's change it to pink so it matches the color. Should end up at 1,360.8 grams. I can even plug this back in my calculator, make sure I got the right thing. Yep, looks good to me. So this is our answer. Now for 2 steps, it's not super like time saving to do this way. It does save a little bit of time, but it takes also some practice to get used to. So sometimes it feels slower and not worth doing it rather than just kind of doing them separately. But as we get further into chemistry, we'll have some conversions that may take 3 or even 4 steps to do, in which case it does save time. That way you're not doing 3 or 4 separate calculations. You're just stringing along conversion factors to keep canceling out units you don't want until you get the ones that you do. So I promise this will be a helpful skill in the future. We're not just trying to make you jump through hoops. Let's keep going. All right, rewrite your answer from question 3 by using scientific notation. Okay, so scientific notation is a way to rewrite a number to make it look different, but really the value has to still be there. So the number that we're changing is this 1,360.8 grams. So I'm going to write this down here, 60.8 grams. And just like our conversions, the value of the unit, the number here shouldn't change. So when I'm talking about 3 pounds, or if I say 48 ounces or 1,360.8 grams, that all means the same amount of weight or mass. All the same amount of matter is there, no matter which way I say it. It's just a different unit to describe it. And the number looks different as a result because the units mean a different amount of mass. Okay? Scientific notation just changes how we represent that number. So the units don't change, the meaning of the number doesn't change, and if you undo the scientific notation and punch it into a calculator, you get the number like this. So in this case, let's try and shake this up and make this look a little bit nicer. The way that we change something into scientific notation is that let's pick a color. Let's do this kind of turquoise-ish color. We move the decimal place so that it is right after the first kind of actual number, the first actual digit that's not a 0. So like in this case, it's going to go after this 1 and before this 3. Okay, so instead, it's going to look something like this: 1.3608. Okay, now looking at that, this is a very different number. So I can't just put grams on here and say, hey, I moved it and made it look nicer. Well, that's not the same number. So we can't really say that. So I shouldn't at least leave it there. That'd be bad. Can't just change the number willy-nilly. So if I want this to mean the same value, if I still want this to mean 1,360.8, what we do is we multiply by 10 to the power of something. Okay, where that something corrects this number to be what we're actually talking about. Okay, so some things about this number that goes up here. Since moving our decimal place is basically changing our number by a factor of 10, that's why we use this multiplied by 10. 10 is our base here, and we change by a factor of 10 to kind of mimic that moving in the decimal place. So every spot that you move your decimal place, past a number, past a number, past a number, is what your number is going to be up here. So this number, kind of swing this over here, is spaces moved by your decimal place. Okay. Now this number can be either positive or negative. So I'm going to do a little positive negative thing here. All right. Whether it is positive or negative depends on how we are moving it, which direction we're moving it. So if it is positive, that means that if we worked out the scientific notation, it's going to make a bigger number. So the positive means we have moved the decimal place to the left, and our number looks smaller than it actually is. Okay, so we use positive if this has been moved to the left. Okay, therefore, we use a negative power, a negative exponent, if we've moved that decimal place to the right. In that case, we're making a number look bigger than it actually is. So having 10 to the negative power of something multiplied to it will shrink our number back to its actual size. So in this case, in order to make this the correct exponent, we've moved our decimal place to the left. So it's going to have to be a positive number. I'm not going to write a plus. I'm just going to leave it positive, no negative sign. Okay, and we moved 3 spots to the left. So this is going to be a 3 up here. Okay, so in scientific notation, this is 1.3608 times 10 to the third power, and our unit is still in grams. Okay, and again, if you're not sure if you did this right, a lot of times if you plug it into your calculator and say, hey, I want 1.3608 to be multiplied by 10 to the third power, it should work it back out. So you can kind of check yourself that way. Now, again, this doesn't look all that much nicer for a number like this. It's kind of like, well, I mean, you still got a bunch of digits here, and now I just have this 10 to the third power here. It looks worse, actually. But we end up needing scientific notation for numbers that are very, very big and very, very small. For instance, the charge of an electron, if you're to actually measure it, instead of just saying that's a charge of -1, is like 1.6 times 10 to the -19th coulombs. Like super small, like 0.0000 a whole bunch of times, and then finally you start getting numbers. Okay? The number of particles in, just an everyday sample of chemicals can be times 10 to the 23rd, okay, which would be like, 23 zeros after your first number. It's a nutty amount. It's huge. So we use scientific notation for some of those ridiculous numbers for stuff that is very, very small or very, very big. So even though it doesn't look super helpful here, it will be helpful later. Again, I promise. There is a reason we're doing it. Okay. Now, let's try another thing. We're going to convert our answer from question 3 from grams into centigrams. So we're going to start back with this 1,360.8 grams. Let's see, oh, my pen just went out. Let's see if I can fix it by putting the batteries back in. Okay. The nice thing about metric conversions is we don't need to do any multiplying or dividing. There are ways you can do it. It works the same way. Okay? But since metric prefixes are just all off by a factor of 10, all we have to do is move our decimal place around. So let's look at, well, actually, it's right here. So we're taking this 1,360.8 grams, and grams is a base unit. Okay? Liters and joules and seconds are also different base units that we might use in chemistry. So grams is our base unit here, and our value is 1,360.8 of those grams. Okay. If I wanted to change this into centigrams, then I would be moving my decimal place. Let's use a different color. We haven't used green yet. Okay. I move my decimal place the same way I would move on this chart. We have the prefixes kilo, hecto, deca, our base unit, so just regular grams or regular liters, no prefix, deci, centi, and milli. And these get tagged on the front of one of our base unit, like kilograms or milligrams. In this case, we're going to centigrams, okay, which is the letter C for its prefix that we stick in front of the G for grams. So to get from regular grams, my base unit, no prefix, to centigrams, I'd be moving 2 spots to the right. My decimal point does the same thing. So it's going to go past this 8, past this 0, which we don't see yet, but we can just kind of place there. So our answer is going to be 1,360. Oops. Well, we keep going. So really, it's not going to be that. We have the 8 and then the 0 after it, and then my decimal point ends there. So really, this is 136,080, and now my unit is centigrams. Okay, again, I can't just call it grams because that number is totally different. Okay, but centi is talking about a smaller amount of grams. It's a smaller unit. It references a smaller amount of mass. So if I have more centigrams, that's because it's a smaller unit. Okay, so these two are equal. Okay, 1,360.8 grams is the same as 136,080 centigrams. It's just a different way of writing it. And a lot of times we can move the prefix around to make this number look nicer, like making a big number look smaller or a small number look bigger. Okay, let's do another example. Convert your answer from question 4 above from centigrams into kilograms using the chart above. Okay, so we're going to take off with this 136,080 centigrams and convert that. So I'm going to write it down here so we can kind of have it again. 136,080 decimal point centigrams. We're changing it to kilograms. So let's move our decimal point. We'll use orange this time. We haven't used orange in a while. And this time I'm starting from centi and I'm moving over to kilo. So I'm going to be moving all these spots. 1, 2. We do count the base unit as a spot, as a prefix, so we're moving past that. So 1, 2, 3, 4, 5 spots to the left. Okay, so our decimal point has to do the same thing. So this is going to go past the 0, past the 8, past the 0, past the 6, and past this 3 here. Okay, so this would be the same as saying 1.3608. If you wanted, you could put that last 0 if you really wanted to. Kilograms, kg. Okay, again, means the same amount of mass, just a different way of writing it. And you can do this with any prefixes. You can start from any prefix and end in any prefix. It doesn't have to start at a base unit. Okay, just like we showed here, we can go from centi to kilo. Okay, as long as we keep track of how many spots we move on the chart and what direction we go in. If you ever want to memorize this chart, it is very helpful in science. I would just kind of go by the letters. They're a little bit easier to remember than just like the names of them. So KHDA, base unit, DCM, might be good to kind of float around in your head. So that way you can move your decimal point around as you need to pretty easily. All right. Oh, I haven't been circling these. That's okay. Okay, it looks like this is the last one. We're going to rewrite our answer from question 5, which was this guy up here, using scientific notation. All right. So that was this 136,001. 136,080 decimal point centigrams. All right, I'm going to be moving my decimal place back to the original digit. 1, 2, 3, 4, 5 spots to the left. Hey, which is kind of like what we did here. Okay, so this is the same as saying 1.3608 times 10 to the 5th, because we're going boom, 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 5 spots. And since we're going to the left, this number looks smaller than it actually is. We need a positive exponent to make sure that it would return back to being big if we multiplied this out. Okay? And my unit is still centigrams. Okay? Now you'll notice that this 1.3608 and the 1.3608 is the same in both of these. Okay? So you might see how changing your unit can be a little bit easier than just, going through a whole scientific notation process. Okay? I can say kilograms rather than doing this whole times 10 to the 5th nonsense if I know how to move my decimal point around pretty well. Okay? They're both equivalent. They both work fine. It's just kind of a preference thing. And sometimes this can be easier, just making a new unit that fits better than trying to say, well, I have a really big amount of this very small unit, and therefore I have to use scientific notation to talk about how big this number is. So hopefully this has been a helpful kind of review. One of the things we didn't cover here is doing scientific notation for really small numbers. So again, just be aware if you're going from a very small number to a bigger number, let's say we're doing 0.0016. Okay, let's do liters. It doesn't really matter. Okay, and I wanted to change this with scientific notation. Boom, boom, boom. I've been moving 3 spots to the right, which means this would be the same as saying 1.6 times 10 to the -3rd liters. Because our answer is actually going to be smaller than what we're writing here, we want to make sure that when this works out and we multiply by times 10 to the -3rd, that is going to move our decimal point back to the left where it kind of is supposed to be. We're just kind of hiding it there. So hopefully that's been a helpful review. And again, this should help you get through this first part of chemistry, and it'll make it a lot easier.